A&Co, and I'd like to introduce him to you while we get him on board. So prior to becoming the CEO of A³&Co, Amr Nader has a record of 20 years of working with the built environment with cement executive teams and business leaders in 50 different countries, including at Lafarge in the Middle East, Africa, South and East Europe, at Orascom in the UAE and in Pakistan, with ASEC in Egypt, with Smart Specialized Services in Jordan, Oman, Saudi Arabia, Egypt and Iraq, and at Yanbu Cement in Saudi Arabia, of course. Amr, can you hear us today? We can't hear you, so we need to, there you go.
Can you hear me?
Now we can hear you, now we can hear you. Great. So if you wouldn't mind sharing your desktop with us, that would be fantastic, and putting your PowerPoint into presentation mode. Thank you. Excuse me. So Amr holds a degree in chemical engineering and a postgraduate degree in digital business from the MIT Executive Education and from Columbia Business School. And in addition, he holds several active business certifications. Amr, it's great to see you, and we can hear you as well. Your PowerPoint is in the right format, so please do go ahead and give us your presentation. Thank you very much.
Thank you very much, Rob, and I'm very glad to be with you, as usual, and great conference. Today, I'm going to address process excellence as a driver for optimal decarbonization. The problem with process excellence is recently with new advancements and the challenge of climate, we overlook this part, which is, from my point of view, a basic and very important part to advance on the climate agenda for the cement sector. First, let's have a quick look on the decarbonization of the cement sector now, and according to the global stocktake, in a recent paper released by McKinsey on 17th of November, which is very recent, cement was seen as actually required emissions 2.6 on 2015. On 2019, again 2.6. This is the actual, consequently, zero rate of change. From a target perspective, the cement sector was expected to reduce down to 2.5. This is McKinsey according to the global stocktake, which is not yet, as a full report, not yet released. But if we look at other numbers, like from the IEA, it will show clearly that cement was not steady on 2.6. It was increasing from 2.15 from 2015 till 2022, with a minor drop on 2022. Yet the numbers are still growing, not reducing. And as an expectation on 2030, it should drop to around 2, with 0.4 the share of carbon capture, which also highlights the minimum expectation of carbon capture by 2030. So focus of the cement sector till 2030 is not on carbon capture. It's mainly on the levers that are dependent on existing technologies with high RTL and the classic levers of process excellence or operational excellence. If we look at the numbers coming from our golden data, it's even worse. You would see that Asia is directly climbing, and even Asia, excluding China and India, is also climbing. So it's not only China and India that are adding to the CO2, there is other countries that are increasing as well. If you look at the lower and middle income countries, they are also increasing from a CO2 perspective. So we could take from that that generally speaking, CO2 emissions from cement industry up to 2021 is not under control and is not dropping. And this is a very serious issue that cement sector need to act urgently, quickly, and reduce emissions with the available technologies and available levers. In addition, of course, to R&D in the future, whether it's oxy-fuel, belite or calcined clay, belite cement or calcined clay, or DAC or CCUS, or even hydrogen as a fuel or hydrogen as a green fuel for power. If we looked at the map, if we removed China and India, which have darker colors, you still have Russia, Iran, Saudi Arabia, Egypt, Algeria, US, Mexico, Brazil, Pakistan, Thailand, that are countries that are under focus, followed by South Africa and most of the African region and parts of Europe. Those are the countries under focus. Those are the countries that are producing between 5 million and 15 million tons of CO2, which is quite significant values and should be addressed urgently and very quickly. Moving from that, we need to look at what is operational excellence. Simply, there are two drivers that are usually moving the cement sector, the continuous improvement and the operational excellence. The difference between them is operational excellence is a strategy. Continuous improvement is a reaction. And the problem on acting on reaction is if things are good, there is no reaction required. The point with operational excellence is that it's an intensive strategy with a mandate, with a timeline. And this is what we need to implement in most cement sector currently to ensure that if not bringing down the CO2 emissions by 10-15%, at least not increasing that. Operational excellence, as I said, as a strategy, it starts by strategy development, implementation, tracking and monitoring, upgrading the capacity building of the teams, finally reach to performance management. If you look from an implementation point of view, it is implemented on a business model perspective, covering all the parts within the cement plant and the cement company, reaching to business unit quick wins and business unit excellence readiness. So this part is very important for cement management to act upon, to focus upon, in addition to other activities being done. Plus, operational excellence acts as a base for the other levers. For example, operational excellence will allow lower specific consumption and lower specific power consumption, consequently lower fossil fuels utilization, and definitely lower carbon emissions. In addition, operational excellence enables a plant to produce higher clinker quality, which is a direct lever required for higher SCM. Similarly, it also enables a plant to reach optimal operation, which is a baseline required for higher AF utilization. If we could push SCMs up to the level of 45% or even 35%, which is a CEM2 level, and AF up to the 35%, which is highly achievable within the current technologies, and bring down specific consumption and specific power consumption to the VAT levels that was assigned by the World Bank in 1998. If we could achieve those alone, we are talking about a reduction of specific consumption of carbon to a percentage of 15, maybe up to 25% at almost no capex. This is the low-hanging fruit. This is what we need to act upon. This is what the cement sector needs to focus quickly upon until 2030. This needs to be on the agenda of every cement company. If you looked at a more holistic approach of a roadmap that covers that, it is a roadmap driven by reducing carbon while reducing cost. We know that all markets in the cement sector, or mostly all of them, are currently oversupply, lower demand, which means that prices are under pressure. Consequently, cost reduction is a lifeline for the cement sector in any place. Consequently, achieving those blue boxes, operational excellence, product portfolio optimization, which is mainly based on SCM increased utilization, waste heat recovery plus waste to energy, whether it's RDF or biomass, This alone can bring down the current levels of CO2 up to a 47%, let's say at least 35%, which is exactly what is required before 2030, or it's going to be too late. This can be complementary with calcined clay in countries that doesn't have limestone to minimize export and movement of clinker, which is scope 3. And if we looked at scope 3 in some integrated units, we are talking about a percentage of almost 75% of emissions, which is mandatory to bring down according to SBTi. That doesn't mean we neglect the red levers, second generation oxy-fuel, CCUS or DAC hydrogen fuel, but this need to be the R&D focus, not the implementation focus. Finally, using this silver bullet of circularity, which is mainly leveraged by using SEM, which simply means using waste concrete, waste demolition wastes, other material to be carbonated and used as SEM, or co-processing, which is utilization of landfills as waste to energy solutions. This is a win to everyone. It's a win to the industry by reducing cost and reducing carbon, win to the environment by reducing carbon emissions and methane emissions because we are tackling the landfills as well, and of course a win to society, bringing costs down and acting on sustainable waste management solutions, where we are talking about massive amounts of waste that are being produced from many different items. I know that the triangle of waste has the firing at its bottom, but we are not acting very well on the recycle and reuse. So it's better to fire rather than keeping it as a waste. As I said, not only CO2 reduction, but also methane and economic value addition by using waste as an added value method. To go deeper into decarbonization, we need to look at the levers at our hands. We have levers that are at almost no capex, or at least at a capex that is within the reach of cement sector. Consequently, no need for financial institutes, no need for maximum incentives, no need for, and it's a good place to produce carbon credits as well, especially in voluntarily carbon markets. We have the traditional levers. Those are thermal energy efficiency, electrical energy efficiency, clinker quality, product portfolio developments, alternative fuels, alternative raw materials. This in all countries except China, India, Europe, and the States are considered as additionality levers, which means generation of carbon credits with a very good payback on the projects and implementation. In addition that they are very low capex projects. The maximum capex in these projects is $20-25 million per a 10,000 ton per day plant. Second lever, which is also very important and very direct, and it's considered an OPEX lever even, is the digital levers. The end-to-end automated process, the digital twins, process expert controls, quality expert controls, utilization of AI, which is highly developing these days at a very low cost and a very high impact, digital asset optimization, interactive decision making models, digital asset reliability. All these levers are OPEX levers, almost no capex, and with very quick paybacks and immediate impact on efficiency and consequently sustainability. Added to that, some advanced levers like using clean energy whenever clean grids are available, whether it's solar, wind, or green hydrogen driven, waste heat recovery, calcined clays for countries that doesn't have limestone and consequently will require the import of clinker, activated SEMs, which is utilization of the flue gas of the cement plant without requirement of pressurizing the gas, using the gas as is, to activate calcium and magnesium rich either novel material like basalt or clay, non-kaolinite clays, or even bypass dust, or wastes like some plastics or some glass to produce SCMs and decrease the utilization of clinker and cement, including, of course, the direction to produce alternative building materials. So this direction, though it's quite good, will not compete with cement within at least the coming 10 years. In addition to a great solution, which is Belite cement, and it's highly overlooked in many countries, and it would be a very good solution, especially in countries that have high clinker production capacities. Finally, again, the high investment levels, which are the future and are the only way to achieve net zero, but their contribution is no more than 25 or 30% of the CO2 of the total cement plant, which is oxy-fuel, CCUS, DAC, electrification, and hydrogen fuel. This will take us to the future cement plant, which will embrace digitization, sustainability, and trends to earn competitive advantage and build resilience. Thank you very much. I'm finished with my presentation.
Thank you, Amr, for a nice presentation, and thanks very much indeed for showing us the way towards a fairly low cost. Just keep your slide up if you wouldn't mind. Fairly low cost decarbonisation through process excellence. Thank you very much indeed. Just like to remind our audience that they can ask any questions via the questions tab. I have a couple of first questions, Amr, if I may, and the first is, what should be the very first steps that a cement plant should take if it wants to start looking at decarbonisation?
It's a great question. I was just in a discussion with one of the major producers in the Middle East, specifically in UAE, yesterday. And this question was exactly asked like that. Simply speaking, if you don't have the minimum specific heat consumption and minimum specific power consumption and maximum utilization of your assets, especially the raw material, raw mix design, and producing the highest possible quality of clinker, you are not ready to start decarbonization, because whatever you will do will have an inefficiency factor to it, and your investment is not going to be optimized.
So really, you need to just look at your current setup and optimize that.
We have produced, as a cement sector, the BAT, Best Achieved Techniques, on 1998. And it's a very well-studied and well-done document that was done by the World Bank, and a huge number of experts has been part of it. Within the BAT, we have numbers for specific heat consumption, specific power consumption, and clinker quality. Those numbers, very strangely, are not achieved in at least 80% of the cement sector globally.
Yeah, well, with that kind of brings me on to my next question. I'm going to ask a very, very quick poll, and it's this one. How easy is it to get funding for capital expenditure projects? And I've phrased this in terms of COVID, but is it easier than pre-COVID, so easier than it was maybe in 2019? Is it the same as in 2019, or is it harder than it was previously, say in 2019? How easy is it to get funding for capital expenditure projects? And I'm going to only give you 5 seconds on this. 5, 4, 3, 2, 1. I'm closing the poll. Thanks to everybody that voted. And this is what you said. It's very clear that it's harder than it was pre-COVID to get funding for capital expenditure projects. So, Amr, what should people do if they've got essentially no money for capital expenditure projects? What can they do?
Exactly what is this presentation is all about, Rob. Go for the solutions that doesn't need capital. We are delaying everything, waiting for capital. And to be honest, we have a lot to do without capital In addition, I would debate a bit the result of the poll. Capital is available. I have discussions with IFC, with EBRD, and with a lot of the big financial powerhouses. The capital is there, but the project's definition, especially with the second move on tightening the capital market, the carbon market, the project's definitions are far away from de-risking the projects and receiving the capital. But the capital as money is mostly available.
Right. Okay. Just one final question here. Many companies are not taking action to improve their processes. They're not optimizing their processes, and they're not actually actively looking at decarbonization. If they're not doing that now, why should they do that in the future?
Two reasons. One is the stick, which is regulatories and frameworks, which is coming, no question. And second is the financial viability of doing it, because it reduces cost and opens the doors to voluntarily or compulsory carbon markets, giving a huge return, and sometimes it's better than cement itself.
Very good. So it's really a bottom line reason for sharpening up your act in the first place, but actually as carbon regulations come down the track, not only will it be advisable to get your house in order, you will be obliged to get your house in order.
Exactly.
Very good. Amr, that's fantastic. Thanks very much indeed. That's all the time we have for questions. Thank you very much indeed for being with us today. And essentially, we look forward to seeing you again another time very soon. I'm sure we'll meet soon.
Thank you very much. Thank you.
Wonderful. Thank you.